All right. Tell me this sounds familiar, please. F of x. Even if it doesn't, just tell me it sounds familiar. Oh, good. I'm glad. No, really, though. Does it sound familiar, F of x? Back from Unit 2. We're going to be doing a lot of that today in 6.1. Remember, F of x equals essentially means what? Y equals. They essentially mean the same thing. Now, this F can change. You can name a function whatever you want. Normally, it's named F, but that letter can change to whatever letter. And what's inside the parenthesis, the input, what do you do with the inputs? Like if this were a 2 right here, like this problem right here. What do you do with this negative 3? What do you mean? Good. You remember doing problems like this, right? We had a whole entire worksheet on this. This was a long time ago. Now, this is just a little background to help you understand today better, so this is not what we're doing. But you should be able to figure this one out. What was the suggestion I made regarding x? Do you remember? Open parenthesis, empty parenthesis. I see a lot fewer mistakes if you were to do that. So I would suggest writing like this, negative 2, open parenthesis, squared, plus 3. What goes inside these open parentheses? Negative 3. All right. Anybody got a number? Was that Maddie? Was that you? What'd you say? Negative 27? Anybody else get negative 27? 1, 2, 3, 4, 5. Guess what? You're all right. You're all right. You're all right. Good job. Negative 27. Uh, Anybody care to explain why it's negative 20? What's negative 3 raised to the second power? 9 times negative 2? Negative 18. And then when you combine this negative 18 with this negative 9, you get negative 27. So, quick little review of some things we've learned about functions. Now, what we're not going to do today, yeah. Oh, good question. Whatever's inside the parenthesis here in function notation acts as an input. And what do you normally do with input? Well, oh, were you here for Unit 2? Oh, man, okay, that's why. Well, and this is a question for everybody then. Do you remember the word domain? What was another word for domain? X values or inputs. They all mean the same thing. So inputs are the same as your X values. It's the same as your domain. So whenever you have something in here that's an input, it always goes in place of X. Or whatever the variable here happens. It doesn't have to be X. It could be other variables, but whatever's in the parenthesis here goes in the parentheses, or goes in the variable for that expression. Okay. Now, this is what we're learning today: operations, add, subtract, multiply, divide. It is so easy, you guys. Function operations, pretty easy stuff. So, let's start with the easiest stuff first, adding and subtracting two functions. There's two ways that it could be asked. It could be written like this, f of x plus g of x. So you may see it on your worksheet today, you may see it asked like this. But if you see this, it means the exact same thing. These two notations mean the same thing. They're interchangeable. Okay? So here's two functions. Now, I haven't really explained how to add or subtract, but I bet you guys are smart enough to figure it out. What do you think is going to happen here? How would you add two functions? Just like terms, right? You can only add like terms, can't you? So, what if I asked you, oh, now what happened? Come on, mouse is stuck. Pretend that didn't happen. So, here's example one. Let's talk about how to find f plus g. And Nate, you just said it. How do you add two functions? Add like terms. Here's what you can do. Write f of x. And I'm writing this in parentheses for a very specific reason. I'll explain that in just a minute. But for the time being, let's write it in parentheses. 2x minus 6. And we're going to add that. What are we going to add that to? 7x plus 11. And again, these should be in parentheses. But now it's just adding like terms. For example, the 2x can only be added to what? 7x, making 9x. The negative 6 adds to 11, making 5. And you're done. Look how easy that was. What's that? It would be written like this on the worksheet. They would say find, like the problem would say find f of x plus g of x, and this is the work that you would do. Nope, 9x plus 5. The reason I had you write the two functions in parentheses, for addition, it's maybe not so important. For subtraction, it is very important. Very important that you write your two functions in parentheses. Yeah, because you're going to be dealing with subtracting negatives and adding all this stuff, so it's easier to keep track if they're in parentheses. So let's take a look. Using the same two functions, g and f, that we used for the problem above, which one comes first? What are we going to write first? The 7x plus 11 function, because that's g, right? So 7x plus 11. We're going to subtract the f of x function. Everybody stop for just a second. Everybody freeze. Stop writing for just a second. I want to explain this whole idea with parentheses. If they're in parentheses, what are you really subtracting? Are you subtracting just the 2x? You're subtracting the 2x and the minus 6, which is what you are supposed to do. If you didn't have these parentheses here, you'd just be subtracting what? You'd be subtracting the 2x from here. So you need to have your functions in parentheses here. But it's the same idea. You can only subtract like terms. So who thinks they've got it? A couple of you? It's a tricky one. What do you think, Jared? Let me write that down and we'll talk about it. Anybody else get this? You are right. Where did 17 come from, though? Minus a negative. Very good. Minus a negative becomes plus. So this is essentially 11 plus 6. 5x plus 17. Any questions on adding or subtracting? That's all it is. Just adding, subtracting like terms. Any questions? No? Let's go on to multiply. These are fun. Now, multiplication can be written two ways, just like addition can be written two ways. So I want you to write both of these notations down so you can be familiar with them. They may ask you to find f of x times g of x, or they may ask you to find f times g. That means the same thing. Now, I bet you guys are clever enough to figure this out. Look up at the screen for a second. What if I took this minus sign and replaced it with a multiply sign? What do you think we'd have to do? FOIL method. So that's what's going to happen here. It's just a FOIL method. So here's two different functions. Again, I chose different letters here. You can use whatever letters you want to name a function. Gotta be a little careful here, though. What is 2x squared multiplied with x? 2x cubed. Yeah, 2x to the third power. So that's 2x cubed, and then 2x squared multiplied with the 4 is 8x squared. And the 1 times the x is just x. And then 1 times 4 is 4. What, note? Something? You need to go get one. And so your attendance on this one suffered? Yeah, you need to go get a note, though, from your teacher. What was I just forgot what we were talking about. Chuck Norris. What were we talking about? Oh, this problem. Any like terms? Oh, where'd you go? Okay, so you're done. What's that? Not all of them have an x. That was the thing. If the 4 had an x, you could factor an x out. But for this one, you're done. There's no like terms. So, yeah, that was easy. Any questions on multiplying two functions? That's really all it is using the FOIL method. Man, we are blazing through this. Well, let's see. We've done add, subtract, multiply. Okay. Put on your thinking caps. Division. Yikes. There's two different ways they could ask you about division. F of x divided by g of x, or it could be written like this. No. Hey, I heard a pretty funny Laffy Taffy joke earlier. You guys ready? Why was the broom late? That close. It overswept. Overswept. Come on. Eden, overswept. There you go. You overswept. So, here's example 3. Let's talk about it. Those are some good ideas. I'm going to ask about some ideas here in just a second. How do you think we would start this problem? I want to hear what your guys' ideas are. How would we start with f divided by g? What are some ideas? What do you think, Maddie? So you're thinking of a problem something like this when we had like 3 minus I on the bottom. Is that kind of what you're thinking? Oh, kind of like the elimination method for systems of equation. I see what you mean. Okay, not a bad idea. What do you think? Let's actually start with the first part you said. What was the first thing you said? Okay, that's how you start. You put, which function goes on top, f of x or g of x? F of x, so let's put it on top. 2x squared plus 3x plus 4. The g of x function goes on the bottom. Now, here's where I need you guys to pay close attention. You guys have some really good ideas. I know this kind of resembles when we were solving systems of equations, how you could cancel, like if this were negative. Do you remember that back in Unit 3? The problem is, are these equations? This is an expression, this is an expression. When you have, what's the easiest way to explain this? Because I know exactly what you're thinking. I bet you're thinking you want to cancel this 3x and this 3x, aren't you? Admit it. That's exactly what you're thinking, isn't it? Here's a phrase I want you to write down and put a star by it or quotation marks or exclamation marks, something. You can't cancel parts of an expression. Only you can only cancel an entire expression with another expression. I'll explain what that means, but for the time being, you need to write this down and burn it into your brain somehow. You can't cancel parts of an expression, only entire expressions. What do I mean by that? This 3x, isn't it part of an entire expression? What's the entire expression it's a part of? It's part of this entire expression, right? I know the tendency when you see a problem like this is to say, well, God, this 3x must cancel with that 3x. What's the problem there? What are you doing? You're canceling parts of an expression, and that doesn't work. Okay? What I mean by you can only cancel entire expressions, later on in Unit 9, you guys are going to see a problem like this. I want you to look at it, but you don't really have to write it down. In Unit 9, you're going to see a problem like this. So far, so good? But what do you notice about the numerator? What can you do to the numerator? What multiplies to 10 adds to 7? So doesn't it factor? So you take an expression and make two smaller expressions out of it. Does that make sense? We've taken this entire expression and made it into the product of two different expressions. What do we have on the bottom? So you can cancel an entire expression with another entire expression like this, but you can't just take bits and pieces of an expression and cancel them out. Does that make sense? Now, we're not going to get to something like this until much later on in the year, but this is just kind of a preview. So I guess what I'm getting at is, does this 3x really cancel with this 3x? No, because it's part of a larger expression. Yeah. There's actually a much easier thing to do. You ready for this? This is the answer right here. You don't do anything. Because you don't really need to. There are, in pre-calculus, which is the class after this, you learn how to divide an expression by another expression, but it's not part of this course. So there are things you could do. This is a simplified. The problem is this doesn't factor. 2x squared plus 3x plus 4, it doesn't factor. So it wouldn't cancel with anything down here. So you just leave it. In Algebra 2, you put the one function on the top, the other function on the bottom. And at this point, since we haven't learned Unit 9 yet, you just leave it alone. There is one small addition, though, to this problem. Do you remember a certain number that you can't have on the bottom of a fraction? Okay, well, you're right. But I'm talking about a real number. 0? You can't divide by 0, can you? Tell me what happens if x equals this number. What if x equals -2? What do you get in the denominator? Is it okay to have 0 in the denominator? No, so you have to include this as part of your answer. X cannot equal -2. Why is it so important that you include this? What happens if x does equal -2? Then it's called undefined because you can't divide by 0, right? I know this seems kind of trivial, but it's pretty important. Well, it's -2 for this particular problem. It can change depending on what the problem is, but you have to have this as part of your answer. Okay. Now, for this one, it was pretty easy to figure out what x can't be. X can't equal -2. For some of the others on your worksheet, it's going to be a little bit more difficult. Here's the trick. You guys ready? It's a simple little trick. You've got to figure out what makes this equal 0. So just set it equal to 0 and solve the equation. If you subtracted 6 on both sides and then divided by 3, what are you going to get? -2. So that's a quick way of finding out what x can't be. But anyway, that's division. So what have we done? Multiply, divide, add, subtract. Is that all of them? It is? We're forgetting one. Add, subtract, multiply, divide. We're forgetting one. You guys don't know about this? Oh, probably because I haven't told you yet. Oh, by the way, there's one more operation. Add a prop to the main office, please. Add a prop to the main office. Called composition. This is the last thing we're going over, then we're done. Composition of functions. Do you have something back there more important than what we're talking about? Cooler than this? Because you could take it out there to not bother anybody else. Okay, composition of functions. Now before well, let's just write, let's not write that yet. Never mind. Let's do a quick little review before I show you what composition is. Let's do it over here. If I gave you this function, f of x equals 2x plus 3, and I ask you to find this, we have done this before. This is back in Unit 2. Plug what in? So you take the x plus 1, and what do you do with it? Exactly. Isn't anything that's in here always an input? If this were a 2, for example, where would you put the 2? Instead of a 2, it's an x plus 1, so you take the x plus 1 and put it in place of x. So this becomes 2, and then open parenthesis, and in the open parenthesis, x plus 1, right? And then you'd continue to distribute, simplify, combine like terms. Anyway, that's kind of along the lines of what a composition of two functions is. There's two ways the book or the worksheet will ask you to find it. It could be written like this: find f of g of x. They could write it like this. Before I show you the other way, let's talk about what this means. What do you think this means? You take the g function, and what do you do with the g function? Are we multiplying it with the f function? What do you normally do with things inside the parenthesis here? You put it inside of x, right? So what are you going to do with the entire g function? Put it in place of all the x's in the f function. So you're taking one function, an entire function, and putting it inside of another function. The other way this could be written looks like this. I don't care much for this notation. The reason for that is it looks similar to something else we just barely learned. A lot of students confuse this with multiplication. So you got to figure out some way to keep it straight. Let's look at the multiplication. A little teeny filled-in circle means what? Multiply. If it's an open, hollow circle, we're talking about this composition. So you got to keep that straight. So let's take a look. Example 5. We're almost done. I promise. Try to extend your attention span beyond the 4 seconds that it usually lasts, people. We're almost done. So, F, what is it? I didn't really write that very well. That's a hollow circle, not a filled-in closed circle. So what does this mean? Composition. Okay, I would much rather think of it like this. Since both of these notations mean the same thing, I think it's easier to think of the notation this way. Which function is going inside of which function? Which function is going where? Which one? The g of x function is going to go completely inside of the f of x function. So what that means is, let me get a different color. This is the g of x function. It's going to go completely inside of the f of x function for all the x's. Okay. So what's the suggestion I made back in Unit 2? What do you do with the x's to make fewer mistakes? Open parentheses. So let's make this x an open parenthesis and this x an open parenthesis. So it's open parenthesis squared minus 2 open parenthesis plus 1. What goes inside of these open parentheses? 2x plus 3. You guys are getting the hang of this. Now, this really stumped my last class, but we have seen something like this before, quite a few times actually. What does it mean to take something and square it? You multiply it with itself. And a lot of them were trying to do this. Well, I'm just going to put the exponent here and put it there. Remember we talked about this? You can't do that. No, that's a no-no. How do you simplify 2x plus 3 to the second power? You can't take the exponent and just put it on both terms. You can't do that. What does it mean to square something? So 2x plus 3 has to multiply with itself. There you go. Remember we talked about this? You multiply with itself. In the middle part of this, you can just distribute the negative 2. That becomes negative 4x minus 6. And then you have the plus 1 there. Be careful on the FOIL method here. Gesundheit. Well, Cal, there's a lot of terms in this one. Does 4x squared have anything it can combine with? Nope, so it stays 4x squared. But the 12x combines with a negative 4x, making 8x. Now let's see, we've got 9, take away 6, plus 1, is 4. And there you have it. Let's have you guys do this one just for practice. You got to get more practice with composition. It's not something that you just watch once and you become proficient at. You got to practice. Now I'm asking you to go the other way around. And this one, trust me, it's going to be much easier. We started with the really hard one. F of g of x, that's the tough one. G of f of x, much easier. Go ahead and try it. Oh, you guys got a good start. We're going to take f and put it inside of g. So now this time, let me erase these lines. Now we're going to go the other way. So this thing here, this x squared plus 2x plus 1, this entire function is going to go inside of that. So I would suggest rewriting the g function, but instead of an x, it's open parenthesis. And then put in the f function. See how much easier this one was? Distribute the 2. And then you're going to get 2 times 1, which is 2. And then 2 plus 3 is 5. Okay. Last one, I promise. Last one. Maybe. Uh-oh, where'd it go? Oh, there it is. Whew. Thought I lost it. Example 6. I'll show you a super easy way to do this problem. It'll take about 2 seconds, maybe 2.5 seconds. We do have a couple of blondes in here. Let me slow us down a little bit. I can't beat around the bush. Oh, for the blondes, that's a figure of speech. I'm not really beating a bush. You're a redhead. Come on, you can't be confused. Okay. That explains a little bit. Now, Trey, you're not a natural blonde, Trey, are you? Yeah. Okay. You're just, okay. Dirty blonde. What do you mean? You got a good point there. I see what you mean. Let me explain the more difficult way to do this, and then let me show you the really easy way. The more difficult way, which you could do and it'll still give you the right answer, but the more difficult way is to find the composition first. So you put the g function entirely inside of the f function. You find that composition, and then you plug 3 into that new function. Does that make sense? That's the more difficult way. The easy way is to think of it like this. This means the exact same thing, does it not? Do you remember there's 2 different ways to think about writing composition? You could write it like this, like F open circle G, or particularly for this problem, I prefer that notation. Why is that? What are you first going to do with the 3? What do you think? Plug it into which function? To the G function. Isn't that going to produce just a number? And then what do you do with that number? Plug it into the F function. So this is a much easier way to do this problem. Much easier, because what's G of 3? 5. And then what's F of 5? 29. Now I know we went through that kind of fast. Let's kind of backtrack here. First you take the 3, plug it into G. So that means this x right here became a 3. 3 plus 2? 5. That's where the 5 came from. So now we're trying to find f of 5. So you take the 5 and plug it into the f function now. 4 times 5 is 20. 20 plus 9 is 29. That's how that worked. That was just part of the problem. That would have been in the original problem. So that's it. Any questions? Yeah. Good question. What do you guys think? No. All right, go ahead. Okay, we're done.